So this is the main piece to the balance. There is a ceramic bearing inside here, and it's going to be a balance to check the differential in force. So this thing's really long. It's what, 3 feet long. Let's look at it from this angle. So it's really big, and being a ceramic bearing, there's no oil inside or anything. So this thing can really check differentials. If you put a coin on here, it's gonna drop quickly. Put a piece of paper on here, it's gonna drop quickly. I can't really. There's no third hand. What happened to the third hand when you need it? I don't think I need opposable thumbs to do this, but anyways. So right now it's moving from a weight differential. Let's see. Well, I don't have anything. Piece of tissue paper. So put a piece of tissue paper on it. Damn it. I can't do anything right now. Just impossible. Well, I'm putting it on the very end. Just by dropping a piece of tissue paper on there, you can see it moves to the tissue paper. Take off a small piece. A piece of tissue paper about this big. Let's see. See if we can get a differential change. Small piece of tissue paper. Yeah, just a very tiny piece of tissue paper. It's causing it to drop. There's also, this bar isn't balanced, so having it drop, and it's even sitting at an angle because my legs are holding it at a 45-degree angle, so it's getting about 1/4 of the amount of force that it would take to move this thing down. Yeah, putting it at an angle, it's going to be it's going to depend on the amount of force deducted or whatnot. So having it at a 45-degree angle, it's going to be 1/4 of the force that is actually, a fourth or half of the force that it's going to be actually producing. So if it was 1 pound of force, then it would be about a half a pound of force being at a 45-degree angle. So yeah, that's what I want to show. Pretty much just how this is set up, like how the bearing is installed. Right there I have screws bolting this together. As it is, if the arms bend, then these aluminum plates do move, so I'm going to put some more bolts inside of it, and then I'm going to cut off the ends so they're actually even on both sides, and then I'm going to balance it. And having one ceramic bearing is going to reduce the friction by a lot. The ceramic balls, well, they don't corrode and don't have any deformations from oxidization or anything like that. So ceramic bearings are going to work really great for this balance. I believe they use pretty much the same concept in the really old scales from hundreds of years ago. It's going to be the same concept. There's weight on this side, there's weight on one side and weight on the other, and then there's, when you turn the machine on, hopefully there's a differential on the weight, and then you'll actually see this thing start slowly moving. And yeah, that's that. And if it's a seesaw design, it's going to be made to actually stop when it gets to like a 45-degree angle or whatnot, and then turn the machine off, and then hopefully it will go back to its original state, or I can play with this design, so that way there's actually a force of resistance constantly pushing against it. So the harder it pushes back, like a scale. And then I'd be able to measure its amount of force. But the main part about this is just to see if there is a differential in mass, or a differential in the mass force. And then if there is, then fantastic. So yeah, ceramic bearings, aluminum bars, and bolted together. And then next is going to be the shaft. It's 8 millimeter? I think it's 8 millimeter shaft. that fits in here. 8mm, 20mm bearing. It's fantastic.